Hello, everyone. Good morning, good afternoon, and hopefully not too late in the evening. Thank you guys all for joining us. We have some really exciting content for you today. I am here with Ying Wu from Aptos Labs. And just a quick introduction for myself. My name is Naya. I am Dune's Blockchain Success Manager, which basically means I have the exciting privilege of being able to bring everyone content like this. Ying will actually be handling all of the actual education. He's going to walk you guys through some very exciting Aptos data, showing you how to decode some of their really exciting projects. So if you've ever been trying to get your hands deep into Aptos data, this is the workshop for it. But before I hand it over to him and let him take it away, just going to run through some quick announcements and exciting events coming out of Dune and Aptos. So as some of you might know, Aptos wrapped up its pretty exciting and amazing event in New York, the Aptos Experience. Several super cool projects and individuals got to attend and see everything that's coming out of the Aptos ecosystem. Some really notable projects like Shelby and Decibel were able to present. Would definitely say that you should go through Aptos's X, catch all of the videos, the photos, everything that you missed, and definitely make sure to add it to your calendar for next year. And then from the Dune side, a lot of you might be aware, DuneCon 2025 is coming up. That's right, we will be in Argentina on November 19th. And if you haven't yet, you should definitely go over to dune.com/DuneCon to sign up for your ticket. Tickets are going fast. We only have a set amount, and last year we had over 1,000 attendees. We have some amazing people who come and present. Vitalik actually presented last year, so if you're trying to get in the door and get the alpha, make sure that you are signing up and getting your ticket as soon as possible. Okay, so that's it for announcements. I'm actually going to hand it over to you, Ying, and you can definitely take it away.
Hi, thanks, Nia. So I'm Ying. I'm the lead data engineer here at Aptos, and today I'll be walking over some of the data that we have on Dune, as well as some of the transform data that I recently put in. So mostly we'll be focusing on the raw and transform data, and then walking through use cases like how do we calculate daily active users and looking at things like stablecoin volume. So currently the tables that we have on Dune are listed here on the slide. We have our raw data, which is on the left side, and then we have two sets of transform data, one around fungible assets and one around stablecoins. There's a few data catalogs here available, and they're linked in the top right. Focusing on the raw data first, as you might expect, blockchain is all first based on blocks. For each of the blocks, this data schema here is how we think about it internally. It's also published on our Medium blog, but the table names might not match one-to-one. So within each block, we have transactions. Unlike most blockchains, we use a version rather than transaction hash as the identifier that we usually join against internally. Version is kind of nice because it's an integer and it's consecutive. So from the transactions, we can kind of map it out into three different things. We do custom parsing for user transactions. We have events, which are going to be like logs from the transactions, and then we have changes from the transactions. The transaction changes are changes to state, and the states can be stored in typically three different ways. One is module, which is the smart contract, resources, which is more of like a struct-based way of storing things, and table items, which is more of a key value-based way of storing things. We also have signatures. Each one of the user transactions also has signatures. So that's something that we also parse out. So I'll be walking through each one of these tables and kind of talking about what they're typically used for. So first we have blocks. So on the block side of things, we typically have a beginning of block, end of block that is mostly just a system transaction. We don't really typically query against that kind of stuff, but Kind of you think about it as like how many transactions are in a block. We'll usually also have start end version, so you can just calculate the diff of that to know how many transactions or how big a block is. These are the types of transactions that can occur. So this is just a screenshot that I took from our Explorer. When you navigate to look at a block, there's a little question mark next to type, and then when you click on it, this window pops up. Let's see. We mostly are going to be talking about user transactions. And another thing that's kind of useful about this table is that if you are interested in proposers or like which validator is the one that the block came from, that information is also available in this blocks table, as well as block timestamp. So that's kind of like the time granularity that we're usually using. Yeah. So on the transaction side of things, this table is keyed on version, and we could also use hash, but most of the time we just use version. The transaction type from the previous slides found here, and in both our GitHub and our Explorer, you can kind of see the various different enums that we have for the different types. One thing about each transaction is that each transaction will use up, that's not a system transaction, will use up gas. Gas we measure in octa, which is a smaller value, and it's a 1E8 for octa to APT. You also have things like VM status and if the transaction was successful. Mostly kind of think of this table as being used for gas or QC, because this table will have the events counts and changes counts. So if we're trying to figure out if we're missing data downstream, we can roll up to this table and do queries against that. So typically this table and the previous table around blocks is not used very often. Next, we have user transactions. So for user transactions, it's also, once again, keyed on version because it's a subset of transactions. But we'll have a lot more information that's parsed out. So first thing that's really interesting to think about is information around who is sending this transaction or what is this transaction trying to do. So we're going to have a sender address, which is the address that submitted the transaction. We have a sequence number for the transaction. And so sequence number is very common also in like Ethereum world, where it's just telling you kind of what order this is in for that sender. And then we also have an expiration timestamp. One tricky thing here is that expiration timestamp is done in seconds, whereas a lot of other numbers are captured in milliseconds. So a lot of people put the wrong expiration timestamp in and it overflows. So that's something to watch out for if you're converting expiration timestamp to time. On the gas side of things, we have the max gas, and we also have unit price and how much was actually used. So unit price is typically 100. This is kind of like the metric that you change if you're trying to prioritize your transaction. We have payload. So this just gives you information about what the transaction is running. We have two types of payloads. One is called entry function. What entry function is doing is that it's calling an on-chain contract. And from that, you can get things like what are the types and arguments of the on-chain contract call. We'll also have scripts. And scripts are just like bytecode that someone uploads to execute. And we can decompile that bytecode using external tools like Ravella, or you can also use the Aptos CLI to decompile. So once you decompile it, you can kind of have a better idea of what's going on. You can also decompile the modules the contracts that are being called in this way. So next we have signatures. So we care a lot about how we allow the user to submit a transaction and how multiple parties might work together to make this transaction go through. So one way to think about it is if you want the best user experience possible, you might not want users to worry about gas and paying gas, especially given that gas is often very cheap. So the first thing to think about is that you might want to be able to have a sponsored transaction where you have an external third-party gas fee payer. So we want to be able to allow that. And then as we were thinking about, kind of like user experience, we also want to allow things like, say, signing in with Google and using that to as your account to submit a transaction, rather than having every user download a crypto wallet. So we also have that. We call that keyless. And two kind of upcoming ways of signing transactions or building transactions that we'll have on mainnet are orderless. And this is really important for if you are, say, running a bot that needs to submit a lot of transactions at once. A lot of times you can run into issues around your sequence numbers colliding because one of the transactions didn't go through, and now all your future transactions are having issues because of the sequence number out of order. So with orderless, you don't have to worry about sequence number anymore. And another one that we're launching soon is a derivable account abstraction, which allows you to use custom authentication logic. So you might be able to, say, use your Solana wallet and just use your Solana wallet to sign a transaction on Aptos. So these are all things that are coming up. So one of the really challenging things about the signatures table is that it's kind of constantly in flux as we have more and newer ways of signing. Oh, we also have things like, multi-sig, where you need a certain threshold, or multi-agent transactions. Here on the right, I have a diagram of what some of our signatures relationships look like. Initially, we had a simpler like signatures class, and now we mostly use the account signature and any signature class, but we need to also keep reverse compatibility. So it gets a little bit more complicated. But if you kind of start from the middle, it's a little bit cleaner. This diagram is available on our GitHub, but just kind of want to point out that there's a lot of different ways to sign a transaction, and we have that because we want the flexibility of being able to broaden the use cases for Aptos transactions. Another thing to note here is that when we think about daily active users, we're always thinking about how many users are signing. So we think of it as if you just had a transaction, if you had an application that's signed for all your users, if the user is not also actively participating, that shouldn't count as another active user. So we always look at signatures when we're calculating daily active users. On the event side of things, events are similar to logs on Ethereum. And it's kind of how you think about it is it's optional information that a contract can emit. So user transactions, we force it to always have one event, which is the fee statement. This event breaks down how much gas is used. The key for this table is transaction version and event index. We weren't consistent about it. So sometimes transaction version has a TX prepended to it. The important fields to look for in this table are event type, and data, which is a JSON. So you'll be doing a lot of like the JSON parsing to get the interesting information out of events. So how I think about events is that a lot of times, if the contract is written properly, events are there to help you show intent, and you build an indexer on top of it so that you can grab what is the useful intent that is occurring for your DApp. Another thing that we also force is that if you are using our primitives on chain, we will emit events. So when coins are being moved in and out of stores, and when fungible assets or like when staking events occur, we even though it might be like composed and wrapped in a script or something, we will still emit events when those functions are called. One thing to note here is that with coins or fungible assets, these are kind of these are kind of like what we use to represent meme coins. We store them in these things called stores. So we have a coin store and we have a fungible asset store. When we had coins, it's possible to store in a custom store so that it is not emitting events. So we migrated we migrated everything over to fungible asset to kind of try and get around this, but this can still occur. And with fungible assets, assets that are created as fungible assets do not have this issue. So that's just something to keep in mind, where you sometimes might see that when you're adding up withdrawal and deposits, things don't always add up. And I have I talk a bit more about that in one of the Medium blogs. So for a lot of times for developers, they might want to track, okay, in real time, what is happening in terms of money movement. And you can go or you want to track what in real time what's happening with a certain DApp. We have a tool for this called no-code indexing that can be found on our developer page. But if you want to look at historical data around how money's been moving around accounts, the data on Dune could be sufficient for that. So on the storage side, in my mind, the most interesting table to look at is move resources. So move resources is when we're kind of holding the structs for a contract, and it's keyed on a transaction version and write set change index. So the main thing to note here is that only changes are emitted. So your transaction could read from a ton of different move resources, but if it doesn't modify any of them, it won't be emitted. And the other kind of weird thing is that when it is emitted, sometimes, because when you scan through everything, you'll notice that sometimes there's no changes, even though things are emitted. That's because when the resources are emitted, it's emitted at the grain of state key hash. Every resource that has the same state key hash is kind of in the same slot internally. So when that slot changes, everything in that slot is re-emitted again. This could be useful for certain situations, like say, for example, you're minting a coin. So when you mint this coin, the supply changes, and when the supply changes, coin info is also emitted because it shares the same slot. Or when you are transferring and you share the same slot with like an object core will store the owner. So it will allow you to be able to say, hey, even though the owner is not changing, or maybe the owner is changing, some of the other stuff is also emitted with it. Some of the metadata is emitted with it. So it allows you to do joins. It allows you to like save one join and like not have to do some lookups. Move address is the owner of the resource, and we have resource types which can be built from move module, resource module, and resource name. We also have another interesting data JSON here, and it's called move data, and that pretty much holds all the useful information in move resources. So we oftentimes will parse this table and we'll filter on one of the move resources or move resource names to get to the DApp that we're interested in. So on the table item side of things, this is kind of to hold things more in a key value way where you're actually having a table. One of the challenges here is that like currently on Dune, it's the raw values are there, but it's not decoded. So it's not really easy to use. One thing to note here is that when you're looking through transactions is that you'll see a lot of table item changes on this particular handle. What this handle is the supply for APT when represented as a coin. After about middle of this year, we migrated over to fungible asset. So you should instead see a change on a move resource called concurrent supply. But prior to that, it was a table item. So pretty much every transaction had this table item change. But yeah, I'm going to skip this one because this one's usually a lot harder to parse and understand. And the data is not currently decoded on Dune. So move modules. This is the last one. It's pretty easy. It's just pretty much the contract. So when you upload the contract gets put in move modules. Once again, keyed on transaction version, write set change index. It also has the functions of the contract and the struct. You can also find this information on our Explorer, I believe. And there's a flag so that you can you can also upload the code along with it. So that's human readable. So sometimes on our Explorer, you can also see what the code looks like. So that kind of that wraps up our raw data. And so I wrote some additional guides on our Medium blog. And the second one in particular is if you really want to go into DeFi and understand how money is being moved around, how coins and fungible assets interact. I go like really deep into understanding what each one of the events and each one of the right set changes is trying to show. Last one's more of information around like recently with stablecoins being more popular, how do we think about like coins as we transfer them, coins and fungible assets as we transfer them, how do we think about metrics like supply and volume? And there's Dune is a great place to find our data, but there's also a few others, and I kind of go over it in the dev page here at the last link here there. If you're familiar with using our GraphQL endpoints, you'll see that we build a transform table on top of events and resources to help with understanding movement of our fungible assets. Fungible assets or coins, this table captures both, have three kind of breakdowns that we use. We do look at activities, which are kind of the movement of money, balances, which is who currently holds the money after a transaction, and metadata, which is things like decimals, supply, what's the name. All these, are, since activities is parsed from events, it's going to be keyed on event index. Balance is parsed from right set change, so it's keyed on right set change. The kind of useful fields here are around asset type, which is our identifier for what the coin is, and amount, owner address. The owner address sometimes is null when we have deletes. I have some comments in the code about how to get it, but since it's an edge case and it's pretty computationally expensive to get, I just sometimes leave it as null. So I'll be kind of walking a little bit more through this in the example, and I could also show like how this, but yeah, I think the example will also be able to show like how this gets used. After I built the fungible asset tables, I decided to kind of go a layer up because fungible assets table is like a very Aptos way about thinking about the data. And if you're coming from more of a EVM world, you're thinking about it as like, hey, how do I get, like everything's being transferred one-to-one. However, for Aptos, you could be transferring and money kind of goes into a pool, and that pool needs to be resolved by the end of the transaction. So it might be unclear there, where does the money actually flow to? Because you could have a many-to-many transaction. Of course, that is an edge case, but when you start talking about money, you want to start capturing some of these edge cases. One kind of powerful way in which the not one-to-one paradigm is used is when you are doing a swap and you need to pay a fee for the swap. You can actually see it then in the example on the bottom right. Say, for example, you are swapping 100 USDC. When you swap 100 USDC, maybe 3% of it goes to a store that's used as a fee, and 97% will go to 97 of it goes to the actual swap pool. So instead of having two sends, you can just have one withdrawal and two deposits, where the two deposits will sum up to be the same as the withdrawal. For this table, what I did, I only built the table for USDC and USDT. Primarily on our chain, we see a lot more USDT transfers. But I wanted to have like a to and from to make it easy for other users to use the Aptos data, because otherwise it's always all like withdrawals and deposits. I create a virtual identifier called a session ID to kind of capture the movement of money. And usually, with this table, you can just look at things like from account to account, and if you want to check, you can also look at the index that it came from. And I go over this a lot more in the part 3 of the Aptos data medium blogs. All right, so the first one, I'll be talking about active users of Hyperion. Hyperion is one of the AMMs on our platform. So the first thing that you'd have to do is you'd have to find, have to find the entry function. So this is the entry function for Hyperion. If you were to go to their webpage and submit a transaction, you'll see that this is the address that's signing. So if you go to our Explorer, you'll see all the transactions that. So first of all, you'll see up here that it's labeled Hyperion, and then you'll also see the transactions that modified resources that Hyperion holds. So these are mostly just going to be contract upgrades, or people sending money accidentally maybe to Hyperion. But this actually won't capture any time the function is called. You have to go through something like Dune to be able to find that. First example I want to walk through is that because we always define active users as signers, let's look through all signers for Hyperion. So this is the query that we'd have to do. So we start with user transactions. We inner join on signers. So this is a one-to-many join, because you could have every user transaction could have one or more signatures. One really important thing here to do is that you need to filter on dates. If you don't filter on dates, everything kind of takes too long. In the user transactions, you have the entry function module. So anyway, entry function address. So you can filter on that just to get Hyperion. And when you run this query, I already ran it here. What you'll see is that for every single day, how many signers are on Hyperion. So that's like a pretty simple way to track who is using the DApp, or how many users were active on that DApp. Okay, close this. So next, with the previous transaction, what we looked at was direct calls to Hyperion. So these are ones where Hyperion was the entry function, but it could be composed where you're calling it through, say, an aggregator, or maybe an arbitrage bot is calling it through a script. How would you capture all calls against Hyperion, not just the direct calls? So in this case, so we're no longer looking at like active users. We're more interested in the number of transactions. And we could always join these transactions back in to figure out how many signers there are. But for this simplified example, just going to be looking at trying to find the transactions and how many of the transactions are direct versus indirect versus scripts. So what I do is that I first start with events, because I know that when Hyperion gets called for their swaps, their recent swaps are all going to emit this event type. So swap event v3. So if I know that they're all going to emit the swap event v3, I'm going to filter my events to find the events that emit this and get the transaction version for it. Next, I join it against user transactions to find out what is the entry function. So if the entry function is null, then that's a script. If the entry function is what we expect, then that's a direct call. And otherwise, that is an indirect call. So when we run this query, what we see is that, as we expect, most of the calls are direct calls, but we have, a pretty even split. We do have some like indirect and script calls. So the indirect calls, from when I looked at it, were oftentimes aggregators. So instead of going to this would be something like 1inch, where instead of going directly to Uniswap, you go to 1inch, and 1inch finds the best swap providers for you. So this is how you get the transactions. Close this. Okay, so actually, before I get here, let's talk a little bit more about this. Actually, no, I'll leave that for the end. So USDT transfer. So another thing that we might be interested in is how much USDT is being transferred. The first thing that we have to do is typically you have to know what is the contract address for USDT. So in our Explorer, we made it so that when you type in USDT, it should just show up as Tether USDT. We have all these other bridged USDTs, but the Tether one should show up here. So if you click here, you'll see that this is the contract address for USDT, Tether, verified. And we have the total supply and like holders and transactions, but this stuff is still work in progress. One of the challenging things here is that the total supply for USDT is not accurate because they pre-mint a lot of USDT into a holding account, and that holding account then slowly distributes out, so they don't need to constantly bridge. So if you actually want to calculate how much USDT is on our chain, you need to exclude this holding account right here. And I talk about this in the part 3 of the Medium blog. But say you took all of the USDT transfers from fungible assets and you wanted to then build it into a transfers table with a to and from. How would you get the total volume then? So this is the query for that. We would start with USDT transfers, which is the transform table that I built out, and then filter on the block dates again, and then use sum of amount divided by 1e6. USDT and USDC and Ethena and USD1 all use 6 decimal points. So you do 1e6 to get the right dollar conversion. So when you run that, this is the number that you'd get. This number doesn't exclude things like wash trading and whatnot. So there could be more filtering done here, but this is just if you want to get raw numbers, this is what the raw volume numbers is what the volume numbers will look like. One thing I'll show you here is that, say, for example, you want to, I think it is important to show a little bit about what this table looks like. Oops. You have things like, your time filters here, your version, hash, the virtual session IDs that built to account, to and from account. So one tricky thing here is that for fungible assets, when you, instead of storing the fungible asset with your address, we create a secondary address to store your fungible asset. We call this a primary fungible store. This is similar to the derived accounts. This is similar to Solana. Solana also has a similar idea where their coins are stored in a separate address, not the address that you have. So this is the store address here for both the to and the from. The amounts, the indices, and then if it's a one-to-many or not. And then if there's been a mint, and in that transaction, what is the rank for this money movement? Because there could be a lot of money moving back and forth in the transaction, and maybe you only want to get the largest amount moved for say filtering wash trading. So next thing. Okay, so I did try and go through this. Walk through this transfer. Okay, so I found a really simple transfer just to look at. So in this transaction here, the TApp exchange, which is another decentralized exchange on our platform, someone swapped about 19 USDT for USDC. So the code for this is also public, but we parse some events and put it down here for ease of reading. But these actions here are all parsed from events. So on the events side, you'll see all this information that's happening here. This information is parsed to then have this USDT transfers table that just says, okay, in the first one, we are seeing from account is C61 is sending to 57D, and they're sending this amount. And then this is going to be the fee that's being sent. So if you go over here, you'll see that this is you'll see the amount being sent here, and then the fees also being sent later on. Let's see, what is the index? 1 to 2. So here's the deposit, and 1 to 2. 1 deposit. Where's the right one? Oh no. Here, yeah, withdraw and deposit. Withdraw, here's the withdrawal, here's the deposit. So things like that. So you can go back to the Explorer to check and verify what is happening here. Another one, is if you want to look at the raw data. So that was going to the Explorer to check the raw data. What you can also do is that you can just query Dune's events table to get the raw data. And this is what you'll find is that the first one is a swap transaction. So that's a swap event type here. And then here is the withdrawal, here's the deposit. So over here, and then the stores that it corresponds to. So this is just, the code's all public on the GitHub, but this is just parsing the data fields here. Oh yeah, so I think I'll do one last thing around walking through the fungible assets. Let's see. So say, for example, the events table is built into a fungible assets table, and then it's built into the stablecoins table. So if you want to kind of like take one step back and see what's happening, you could also look at the fungible assets table. So the fungible assets table will have, let's see, okay, this is a live demo. I don't know how long it's going to take, but we'll have all the movement of money. So if you look over here, you'll see that there is the owners, the storage addresses. You also see the asset types. So what I had already done was that I had already mapped the asset types to the USDT and USDC and the amounts. So one of these is USDT, and the other one is USDC, and then they're kind of moving in and out. And you can see here from the event type if it's a withdrawal or a deposit. If you're looking at balances, you also see that the balances have changed. You have to change this to right. Change index. But with the balances, the ordering in which the balances get emitted, I think has a lot more to do with how the contract's implemented. So the ordering is, if you want to kind of think about and like replay what the contract is doing, you can walk through the events, but the right set change index for the for balances or resources is not as useful. And if you want to be able to like kind of debug visually, there's a website called Sentio that lets you walk through each one of the transactions. So here is kind of the various different, let's see, the various different assets are changing. So this one here is APT, so it's being used to pay gas. And then these are the various other ones that are like USDC, USDT, and how the balances have changed on various different storages. The stores that hold they're either on the user side, which is the user that's did the swap, or on the DEX side for holding both the pool and the fees. Yeah, I think, and then we also have a field around if it's frozen. And V1 here means a coin, V2 means fungible asset. But yeah, we have these kind of useful tables here to make going through the events a lot less painful. Anyways, that is it for my part. And so I'll be going through some of the questions now.
That was very thorough, Ying. Thank you so much. You showed us how to go all the way from the raw data all the way up to event level data. Super detailed, very thorough. For anyone who might be concerned that they missed something, that you might not have been able to see one example, or you jumped in a bit late, no problem. We should be recording this session and we will upload it afterwards so that you're able to pause, rewind, go through everything as often or as many times as you would like. Ying, we are going to do the Q&A now, as you said. Essentially, we have multiple questions here. Some of them are pretty technical. So if you need to, we do have enough time for you to go through and like do some live querying as well to dig into the data. So please feel free and let me know if you need to share screen, and I will make sure that you're able to do that as well.
Sure.
So kicking it off with a bit of a big one. How does the Node REST API map to data that's in Dune?
Sure, I'll talk a bit about that. So a lot of times, you're used to hitting the Node API through the RPC, and we try to keep the format very similar to what the Node API has. Just kind of like thinking about like if you want to retrieve a transaction, the transaction blob can be split into events and right set changes in the way that the tables are split. One big limitation is that we do not allow for querying view functions. So I think on some other chains, a lot of times what gets done is that you constantly hit a view function to retrieve on-chain state. Um, we to get around this, what I typically do is that I reverse engineer what the view function is doing, and then, if possible, put that into SQL and then run that. And so you can get historical you could get what the view function would have returned historically with that. But not everything you can convert into SQL.
Okay. Okay. And if you were actually to go into kind of going back into like going into the data, would you be able to show them exactly like where you would be able to find it?
So with the view functions, a lot of times they're mostly just like putting a bunch of resources together
Mm-hmm.
and trying to get like the past state of resources.
Ah,
You would just be doing a lot of resource parsing to re-implement a view function typically. But I do find that if the contract is written in a way that's meant to be indexed, you
mm-hmm.
can get it through events instead, and that would be like oftentimes much more useful.
Okay, good to know. All right, up next is how to find an entry function for a website or D app.
Let's see. I could live demo that, I think. Let me log in first. Hold on.
Okay, we'll hide that for a moment.
Yeah, so say for example. Okay. So say for example, we're on Hyperion, and we're saying, okay, so I want to say swap some APT for USDC. When I run this, so this pops up here. And so when this pops up, you will see that the entry function is listed here. And then you can see the type arguments. You can see the what we expect the what we expect the events to be, and we also expect the changes to be. So this does a simulation. It figures out what we see from the simulation, and then we also can get the entry function. So these are the three parts of the entry function: the address, the function names, and the function. Yeah, those, I think module and function names are here.
Okay, great. And so, um, taking a look at what else we have here. So next, I find portfolio positions for DeFi.
Yeah, so for DeFi, this is kind of thinking like, if you want something similar to DBank or Zaphion, I think is what they call it,
Mhm.
in Ethereum, we have one called LightScan, and you can see it when you go to our Explorer. The portfolio positions require a lot of parsing of account positions, and so once you have all that parsing done, you can easily figure that out. But for every D app, you need to do custom parsing. And for AMMs, is relatively straightforward. But for some of the clubs and the concentrated liquidity and perps, those are a bit more involved in parsing. Not sure for some of them if you can actually do it in SQL. You might have to be able to do it off chain. I mean, not off chain, but like you might have to do it like with Rust indexer. But yeah, there is like I think LightScan is what they call it, but it's linked on our Explorer.
Okay. And if you were trying to identify the differences between some of those contracts, because as you said, like an AMM, one AMM does not fit all, how would you start going about actually figuring out the differences, how to start parsing? Like, where would you personally start?
Yeah, so typically what I do is that I would dog food it first. I would just use the product, and then because I know what I'm doing, I could then look at the events and the changes and see from the events and changes here, what's going on. It gets like a bit more complicated if it's like a perps or some kind of order book, because one like thing that I do might trigger a bunch of downstream changes. So there's that, but usually that's a good starting point. Is just, you know, you do the change yourself because you know what you're doing, and then you look at what changes occur because of what you did. A lot of times, it's like it's really easy. It's easier if you just go off events and you build from events. Like, say for example, you look at all my trades and you infer based on how much I moved in and out what my
Yeah.
account balance would be. But actually parsing the resources to get account balance would be more accurate. So there could be a delta there, but if you want just like a quick and dirty way to do it, you can just build everything off events.
Okay, okay. It definitely sounds like whoever is watching definitely needs to start digging into some of your guides to be able to see how to start getting into some of that information and making sure to like rewind on this to be able to do that. Because as Ying said, no contract is one size fits all. You got to make sure that you're getting everything, even the details, when you're trying to get the numbers that you're looking for accurately. Okay, next question. What's the cleanest way to visualize wallet flows between sexes and DeFi?
Yeah, so this is the tricky part, is that not all centralized exchange hot wallets are public. So
Hmm.
I did put a lot of them onto our Explorer, but I don't know how many of those are public. So I would like, you know, the community to maintain a list of hot wallets. But once you have that list of hot wallets, which is, you know, pretty easy to find if you're just looking at like the typical flow of the money gets consolidated into a hot wallet. Um, you can then like kind of filter out movement between centralized exchanges. So it's
Yeah.
pretty much just like if you look at things that are one hop out away from a hot wallet, or like two hops out, and see like, you know, just say, all right, this is just a centralized exchange to centralized exchange transfer, which we have a lot of those.
Mhm.
You can then start to see like, okay, centralized exchange to maybe just like a wallet funding, or a centralized exchange to a wallet fund, which then goes into DeFi. So what you would do is, well, what we've done internally is that we've taken that transfer logic, we've kind of built out a few hops from each account, especially around the centralized exchanges. And then you can see like, okay, where is the money going? How much of it is flowing into just accounts that kind of stay there and then don't do anything, or accounts that then, you know, put money into DeFi.
Okay.
We don't have that many DeFi platforms, probably under 10. They're all listed on DeFi Llama. And the other kind of nice thing about DeFi Llama is that in their GitHub code, they also have the module addresses. So you don't have to actually go to their website and like, you know, dog food and like to get each one of the entry functions. They should all be on DeFi Llama. So you can use that to then filter out like, okay, so how many of this money is actually going into DeFi products?
Yeah, you had me in the first half. I was about to be like, oh my God, what about Dune? But yes, you can take that info and you can use it with the data that we have on Dune to make sure that you're able to filter for accurate data. One other kind of branch off question that I do have from that is, what are some aggregated sources of hot wallets? Because you said that you have built something internally to Aptos that may not necessarily be available to those watching this stream. So, where would you recommend that if there is any aggregated sources, and if there's not, where would you recommend that they get started
Oh
on?
no, I built that out on Dune also, the fungible asset balances table. So the
Okay.
balances table just gives you balance changes, but
Hmm.
if you filter the balance table on like the latest one, you'll get like current balances. And with current balances, you can kind of just say like, okay, so who currently owns the most APT? So it's going to be like, you know, some centralized exchanges, some like, you know, foundation wallets, you know, some whales. They're all going to kind of be there, and then you could kind of do some of the research around just like, okay, so when's the last time the money moved in this account, when they get funded. So if something got funded during like, you know, Genesis, it's like this is probably like a foundation or some kind of partner, versus, you know, if this is just like an account that constantly has money moving in and out, maybe in like smaller denominations, like, okay, this is maybe like a backpack or a centralized exchange or something like that. And then so all the building blocks are there on Dune with the fungible asset balances table.
Yeah. Okay. Fantastic. And then next question is, what is wash trading and how can we identify it in the data? This kind of goes back to an earlier query that you were doing live demoing during this stream. I know it's a bit of a big one, but I think it's important to go through.
Yeah, so the wash rating is kind of a way to pump your metrics around volume without it being organic. So one way to think about if, say stablecoins has product market fit is that if people are sending stablecoins to each other, like, if I'm using this as a money transfer mechanism, then there is use for this, like, the product's starting to find like, good to fit.
Hmm.
Well, one way to game that metric is just to send that money back and forth between you and a friend, or even just send that money to yourself. So you could just constantly send the money to yourself, and it would still, if you're just looking at events, you would see that these events are like, if you're just parsing events for volume, then you'll see that there's a lot of volume here. So what you can typically do is you can look at like, okay, so between which addresses are there oftentimes really high volume? And is this like reasonable? Like, say for example, if I see that a lot of money is moving between a Binance and OKX, or like through a few like intermediary wallets, I might just be like, okay, so this is maybe just like market makers moving money around or people
Yeah.
moving money around. But if it's just like, okay, two randoms that just all they do is just send money back and forth,
Hmm.
it might seem like, okay, this does not look organic. This might look like you're just trying to pump metrics and volume. And so what you would do for this is that you pretty much just look at pairs, or you can even look further out and say, maybe I don't want pairs, but maybe like, 2, 3 hops out. What are some of the accounts that constantly send money to each other? And maybe we want to like exclude them when we're calculating volume.
Yeah. Is there a way to aggregate those wash trades into one set of data in lieu of having to? Because what it sounds like is you almost have to take unique like addresses and kind of filter them out. Is there anything
Yeah.
that
So
yeah, okay, go ahead.
So for these, well, for the identification of wash trades, I think one of the
Mhm.
first things you have to do is you have to remove centralized exchanges because it makes the join in SQL really bad. So
Mhm.
once you remove those like centralized exchanges, especially like remove some known actors, like known good actors, and then from
Yeah.
there you could then start to do the join together the trades on that coin and see if there are pairs that's like movement that just doesn't seem organic. um
Mhm.
yeah.
Yeah, that makes a lot of sense. Okay. Next question. So this is more so around what you do at Aptos and what data that you're interested in. So you showed us some really great projects on Aptos, but what is Aptos interested in when it comes to data? What is it that you tend to query on a day to day? And where can we see some of your work?
Yeah, sure. So some of the work that you see, so like the metrics that we care about, we put on our Explorer. And so there's an analytics page on our Explorer with metrics that we've been closely following. One of the metrics that I recently put on there was block time. So how quickly do we generate blocks? This is really important for user experience because if you submit a transaction, you need to wait for a block to become available. It's kind of like, if you're waiting for a bus, you need to wait for, if the bus is leaving, you need to wait for the next bus to come. And then you need to wait for that bus to fill up and then it needs to leave again. So
Mhm.
how quickly are these buses coming? So we think of that as like block time. Recently, I put a new widget on the Explorer for the calculating like, P50 block time.
Mhm.
All the logic for like the queries to generate the stuff on the Explorer, we actually have on the Explorer's GitHub under an analytics page. So all like the SQL queries that you need to generate are all there. So that I think really helps the community if they want to look at something similar. Um, Internally, like I do things like build out data sets around like stablecoins and trying to understand stablecoin volume. I also do things like ad hoc requests around. We recently had a Osaka event and we minted NFTs for Osaka. And so we're looking at like, okay, so how many people were actually getting these NFTs? I think I put that also on Dune, where it's just like you're looking at like this Osaka World Expo and NFTs are being minted for it. And just like, are people using it? And if so, the thinking behind it was more like, okay, this is a Web2 activation where these are Web2 users, but in the backend, they're using Web3. So you kind of like see what users are doing publicly in Web3.
Yeah.
And so for that, it's parsing tokens or NFTs rather than parsing fungible assets or coins. But it's also like a similar like process of just going through move resources and going through the events and like building out what's happening. So a lot of it is just like figuring out what it is we want to track, and then using the pre-existing tools to mostly around events and remove resources to get what we need.
Amazing. A couple things I'm hearing from that is that if we actually go to the Aptos account on Dune, we're looking at queries and dashboards, that you're likely the person behind doing the heavy lifting and building for them. Is that right?
Yeah. So I have a few, mostly for like one-offs, but the stuff on the Aptos account, I think I built most of them. Yeah.
Awesome. Awesome, awesome. Great to think that a lot of our viewers can actually go and like see your work real time. And also, it's really good for everyone to know on the call that, especially when you're getting started and you're looking to understand how particular queries work, besides even going to workshops, you can actually go into where it's public on the Aptos profile, go into the queries, kind of look at the logic, see what's happening behind the scenes, and actually try to replicate it with whatever analyses that you're trying to do. So that's always an option. As you heard, Ying is very competent and knows a lot about Aptos data and has done a lot of amazing things to make sure that the community is able to access this data and run analyses. So please absolutely go and check out his work. Ying, we're going to close out with one more question here, and I think that this is something that everyone gets really excited about. Is there a query to see how many people actually made money this cycle? Asking for a friend.
I'm not sure, but we did recently put in a lot of protocol fee parsing onto DeFi Llama. So a lot of times, like in the example that I showed, the D app will have a split have two separate pools. They have their main pool and they have their fee pool. So you can just look in the fee pool and see how much they made in fees. And so that's like something, and how that fee pool is growing. So that gives you an indicator of like, how much the protocol is making. So yeah, so when people trade, the protocol makes money, but and we have some of that parsed on DeFi Llama. But in terms of just like like the APRs and whatnot, it's all on the web. It's all on like the DApps pages, like what's the current lending rates and whatnot. But I haven't actually looked to see how much people are making.
So it sounds like it is possible. It is possible to check and run a query on that. And then just to make sure that I understand, is it possible to do it on Dune as well, like going into the Dune tables that are currently available? If you do
Yeah. So what you'd have to do is you would just be so for the D apps, you would find their fee pool, which is going to be like a specific address, and then you just parse out how much that address is holding in terms of like how much APT they're holding, how much USDt, how much USDC they're holding, and you can just figure out like how much money they're generating in fees daily. For some of the lending stuff, you have to do some math around like multiplying against positions and like back calculating like what the expected withdrawals would be and things like that. So it's a bit more complicated with a bit more math. I don't know if I have anything public around that yet, but it's very similar to like kind of what Aave and other Ethereum code would look like.
Okay, awesome, awesome. So you heard it here, folks. You can definitely go check out the fees, make sure you're looking at everything, and you'll be able to figure out how much people actually made this cycle. And it sounds like it's a hot topic. So you might actually be able to get editor's choice on Dune if you're able to build out a dashboard that's flashy and accurate enough. So we're going to close out here. Ying, thank you so much for joining us. This has been an amazing conversation. And I hope to see all of you in Argentina at DuneCon.
Yeah,
All
thanks
right.
for the opportunity. Bye bye.
Absolutely. Bye.